Welcome everybody to our new office space. I don't know if anybody has been with our company before or at one of our meetups. It's been quite some time. Uh, okay, so maybe brief introduction who we are if you don't know. We are H2O, H2O.ai. We've been here actually in Prague for quite some time. It's been at least like 8 years here. And the company itself is actually even older. We started in 2012. Back in the Mountain View in the Silicon Valley, and ever since we've been basically focusing on every area of machine learning and AI that moved around since then. So basically, we started with predictive AI. I think we are still pretty well known actually. Sort of like became industry standard for like machine learning on large scale using our open source library called H2O. So we have some authors of the library with us here. But today we'll be talking more about the generative AI stuff, which we basically started with a few years ago as well. So uh, basically our portfolio, I mean, is divided into both like predictive platform and like generative platform, and we focus on like different aspects of both. So as I said, like large scale data, then automatic machine learning. We are, I mean, pretty well known for like pioneering product called driverless AI, which focuses on AutoML, and then different aspects of the ML like interpretability, explainability, and then, as I mentioned before, the generative AI and things like fine-tuning of the LLMs, RAG or retrieval augmented generation, or the topic that we'll be talking about today, which is focused on like evaluations of these large language models or the RAG applications specifically. So that's the topic for today. As I mentioned, we've been doing a lot of stuff in H2O since 2012. There is the generative and the predictive platform, and right in the middle, we have something called the agentic AI, which is I think on uprise, especially like for the last year. And we've been pretty successful in bringing the agentic AI also into the predictive platform, like automating the machine learning training, but I mean in general the machine learning stuff. And we were also pretty successful on some competitive benchmarks such as Gaia. So I mean, if you are interested in that, I mean, definitely reach out to our website, and you can get more information on that. Unfortunately, we won't have time to cover all of that today, so I mean, we'll focus more on the evaluation side. However, to bring you into the context, I wanted to start maybe with this slide, which focuses mainly on how we organize things. So maybe you understand more what we'll focus on, and especially, I mean, which part we'll be basically trying to solve, or maybe like explaining how we are trying to solve within this. So as usual in machine learning, we are often starting with the data. I mean, in predictive, it's usually structured data, usually. I mean, in the world of generative AI, it's often like unstructured data. And we basically have two directions to go. We either can like create the pipeline, a RAG pipeline, for example, which somehow ingests the data and then performs some computation and tries to utilize like LLMs to basically maybe summarize or like give you answer to your prompts, to your questions based on like this numerical representation. Or we can somehow embed the data, which we then call like the knowledge, into the LLMs, into the models itself, and hope for the performance uplift, and maybe like utilize the LLMs itself to basically solve the problem. So that's like the top part of the diagram, where we basically prepare the data. We can, I mean, fine tune the models, and we actually have also set of our own foundation LLMs that maybe you can try because like the top one is actually open source as well. So I mean, it can maybe be seen that, I mean, we are like huge fans of the open source community, and that's why we also like invest back by basically providing the tools and like solving these problems with our community. So at the end of the pipeline, however, is like the most important for today, the most important part for today, which is the H2 EvalStudio. And the part is basically focused on making sure that whichever way you go, like the pipeline works. It hopefully like doesn't make too many mistakes. It eliminates like the common mistakes or common pitfalls of those pipelines, like hallucinations or basically the trustworthiness of those applications. So I'll ask my colleague here, Martin Dvořák, who is like a lead software engineer at H2O, working on interpretability, explainability, and now evaluations of the generative AI applications for quite a few years. So, I mean, please welcome.
Thank you. So I will follow up to like Johnny and his introduction of our product portfolio, and I would like to deep dive or formulate, basically do the problem statement of today's meetup, which is deployment of and creation of GenAI applications and creating such applications for the real world, and how in this context can evaluations help. So you, I guess, are GenAI practitioners. You build the application, so you know the situation which is today. There is a push for building of GenAI applications or machine learning applications from like investors, social media, and in general. However, the reality is like sometimes very different. Can be in simple terms, I think it can be put something like expectations minus reality equals frustration very often. So really, this like what happens these days is that there is really push or even the aim to build such an applications, and sometimes, very often, sometimes in the middle of the way, what happens is kind of a reality check, or we simply find out that the thing is not that easy. So and that's I would say it's not just some kind of a like illusion. It's the reality which is actually proven. So the sad reality is I would say is that like most of the applications on the generative AI pilots simply don't deliver a return on investment. They don't deliver on what was promised. And also almost half of the companies cancel these AI initiatives because they don't lead to expected results. So there is, as I said, like no really will to do such applications to deliver something. However, that actual impact is really problematic and it's difficult to achieve. So that's the problem where we are. The technology is promising, however, the use in the reality, which would like say bring some kind of benefits, is problematic. There are many problems or root causes, or I would say like the common denominators of the fails. So this slide summarizes just a few of them. So it starts with the data and the quality data which are somehow scoped for the domain in which the Gen AI application is used. And these data are, it starts with the training data for the models, the corpus data which you have in a RAG, and also even the evaluation data. So all aspects of that are really important. The scoping is important. The context in which it's used is important. Another problem is the maintenance, because these systems really decay fast. The world is moving fast, the data are changing really fast, and the way how these systems are used also changes, so they need to adapt. So it doesn't end with actual deployment, but there needs to be mechanisms which keep such systems like in a good shape. Trust, explainability, and auditability. So this is also important part of these applications. There must be transparency in what's being done there. There must be mechanisms which explain how the system makes the decision. There must be the way in which authors of the system can describe how that operates, and also that transparency is important for like iterative improvements of the system, to be able to find out in case of any problems or any other things, to work on that. Governance, as in any other enterprise software, then these GenAI applications needs to be part of some governance within like huge organizations, some kind of a process which controls their life cycle. Also, they need to be compliant, and the risk associated with their operations, especially if they are customer facing and they are used by outside of companies, must be somehow managed. So there are legal reasons, there are obligations, and also there are various risks associated with that. And the last two bullets are basically about the adoption within the organization. Again, setting up the expectations, setting up, or I would say working with users on how to use these applications, what's their purpose, what it does, what it doesn't, and also managing the change. Sometimes with the GenAI applications, you may update some component of that, like LLM model, some part of I don't know, switch the embeddings, and the end system starts to work differently for the users. There are somehow already adopted for certain weaknesses of that system, but they shift in some way, and then there might be like that sentiment which is not that positive, I would say. So there are even many more problems which are associated with that. So the evaluation process for these GenAI applications really aims to cover various aspects and to be in some sense holistic. So it starts with the accuracy and relevance. So how good are the actual results? But this is not just this is not the end. That evaluation process needs to cover things like the fairness, like obvious things like the toxicity of answers or some kind of a bias which may be related to gender, some demographical stuff, age, for instance, and so on and so forth. Resilience and I would say robustness or sensitivity of such system is also a key thing, because if it's used, for instance, by like humans, people like do mistakes, they don't use grammar as expected. So such system must be resilient, towards some kind of perturbed inputs or not that friendly inputs which are not that done by users with good intentions, and so on and so forth. Apart from these like functional architecture stuff, there is also system level. So the speed, latency, and efficiency of the whole system is really important. And what that evaluation must do, it must in some way to calibrate the expectations for the use in the real world, because upfront you need to know things like the cost, for instance, or similar things, because they are key for successful operation of such thing. Interpretability and traceability, I touched it earlier, but as a part of the evaluation process, these things must be again checked, validated. Then it must comply with the things which are in place, and also it can be used for pinpointing the problems and iteratively improving and fixing such application. And finally, there is a business impact and utility. So it's kind of the last step. And as I said, setting the our calibration of the realistic expectations, capabilities, operation costs, and all these things are key for the adoption. So that's in brief, what such evaluation should do. And I'm like here again showing the diagram of what we do. And EvalStudio is answer of H2O to these requirements, and it uses a systematic approach for evaluation of GenAI applications and RAGs in particular. This is based on the framework which is called model risk management, and the product is basically built around that. And Johnny will now do the deep dive into that MRM system.
Okay, just briefly focus on what we mean actually by our response. So, okay, we introduced the company, maybe like what's the problem, and now it's like time maybe to describe what we are trying to do, or maybe what we are trying to achieve, like about these problems. I hope they are clear. We can definitely return to them like later, but let's talk about the MRM. So is anybody here familiar with the term MRM, the model risk management? Anybody maybe from the fintech industry or banks or something like that? Okay, so the MRM, I lost the connection again, excellent. Okay, so the MRM, the model risk management, is sort of like we could call it like methodology, process, basically like necessary piece within like usually larger company processes that basically takes care of the risk associated with using complex, often AI or mathematical systems, tries to like detect various like failure modes, tries to often like suggest what can be done to mitigate. And more, I mean, important as well is definitely like to classify the models into like several risk categories. This is probably not very well known yet. I mean, in other industries, but if you are familiar with something called like EU AI Act, sorry, and this, I mean, similar thing happening in the North America, it may be possible that it comes to front much often, or to news even like much often in upcoming years. And the reason for that is that until now, basically, there was no regulation or basically no definition of the responsibility of using such models in productions. So just if you ask like what happens if the model makes mistake and you basically don't get the loan, or I don't know, basically you get like wrong recommendation. You know, sometimes it's like less serious. Maybe you will be living or you'll be staying, I mean, in some dumpster in wherever you go through booking.com, but maybe it's much more serious where, I mean, you basically lose money and, or even like some maybe like health damage. And then where's like, I mean, the real stuff comes and there needs to be basically some process to mitigate or maybe do something about it, or like from the company perspective, being able to tell that we did basically everything we could to avoid such risk. And okay, there is always some percent of like cases where just things don't work out perfectly, but I mean, we can at least try, right? So the MRM is about that. And as MRM is pretty complex thing to do, I will be demonstrating it on like pretty simple use case, which is actually like pretty common across our customers. What they are basically trying to do is they have, or they used to have, call centers, and they are often like trying to replace the assistants they had by the generative AI models. So they feed in basically tons of documents about like company policies or some, you know, recommendations, some rules, and then let people ask those systems or those generative AI systems about the documents and provide the answer, same as like normal human would do. And obviously there have been already like a few cases where the advice given was like pretty bad, caused some financial or even like health damage, or well, led to maybe like some wrong decisions being made on like high levels. So very briefly, I mean, visually what the call center means, as I said, like we have a customer, the customer is basically, in this case, the bank customer is asking questions about, for example, I know what I need to do to get a credit card, or what's the limit of the money I can get on my credit card. We feed our like bank policies and bank rules into the RAG, the retrieval augmented generation. I hope like the term is now like settled system, and connected with the LLM, the model is basically able to provide answer, hopefully informed and less of the hallucinations, to the given query. And if the system is not, Hopefully there is some sort of like safety guardrail, as we call it. We'll get to it later. Basically some, prevention mechanism that prevents the system to, let's say, answer it incorrect answer, or like at least being able to tell like, I'm not quite sure, there should be probably some human involved. So this is like the just high level picture of like what we were trying to do. And well, as I said, our solution to making sure that there are no problems is the methodology called the model risk management workflow in the EvalStudio. We'll go through the steps to each of the steps of our proposed or our curated system for this. But before that, I actually wanted to talk like why this is a problem, why this is like so big problem that basically not every company in the world does that. Because like, naively you would think like this is so important, like obviously this is something I need to do before like putting something into production, right? Well, no. And the problem is that, well, first of all, it requires experts. Like just to basically evaluate such complex model, as LLM, and even like simpler one, even if you would be using some, linear equations to basically model something, you need expert, mathematics, statistician, maybe like somebody who also has some sort of like domain knowledge to understand why the decision was made. We have tools definitely like that can make it like more easy. We actually work on them with like my colleague Martin here, and we can basically introspect like the behavior of the models. But as the model gets larger, this is getting more and more problematic. So first of all, we need experts. Experts are expensive, if nothing else. Expert work is often like time consuming, and well, even more important, there are not enough experts, in the world. So that's first thing. The second thing, as I mentioned, we need like domain knowledge about like the problem. So let's say the model that's focusing on like the banking industry is completely different than like some agents that, I know, helps you with the sport matches, so, like fixings for matches or whatever you do in your free time. So obviously we need experts in every domain. So again, we need people. And finally, we need to assemble the data. And this is like very crucial point because, well, conventional methods, we can call them now, like benchmarks for like these kind of systems, often come up with some sort of like synthetic data that's completely torn out of the context. And we just cannot like say, oh, my banking assistant is not hallucinating because it was not hallucinating on, I don't know, MMLU or some sort of like artificial data set used for the benchmarks. We definitely can benchmark LLMs, and there is definitely like point in doing something. But when we are putting things into production, we definitely need to make sure that it works for our use case. And this is like super important assumption that I want to underline. So we are starting with the data, and we are scoping the problem, or we are scoping like the solution to specific data set. That's why we have a RAG. The RAG basically contains like corpus, the knowledge base of the of our problem, let's say like banking policies. And we need to make sure that the system works within those boundaries perfectly. It can maybe hallucinate, I don't know, if we ask about like bicycles, sure, like it can make mistake. But if it's like it needs to answer questions to queries about the loans, credit cards, I don't know, some, well, lease periods and stuff like that, absolutely correctly. So that's like fundamental. Okay, so maybe to clarify also like why we took on basically like tackling these problems, or why we think actually that we can do something about that. We have like a long history with kind of like interpretability and explainability kind of things, and we have experts. We developed this model risk management framework with a guy called Agus Sugianto. Agus is actually a pretty well-known figure in banking industry. He's been doing the model risk, or he's been actually leading the model risk department in like top world banks, and he knows a lot about the processes. So he came up with a methodology that can be generalized to like arbitrary RAG systems, and hopefully can be also used, outside of the bank industry. in, well, whatever other industry. So that's the first thing. Second thing I think we are pretty good at in H2O is actually the automation. As I said, like we worked on like this pioneering AutoML platform, and we feel that we actually have something to say about like how to make things smoother, how to make things even like maybe less expensive, in less need for the people and stuff like that. So that's definitely one ambition that we have. And then obviously like we also developed some sort of know-how about like explainability, interpretability over the years. So I mean, we collected some curated set of evaluation techniques that cover different aspects of the evaluation, because obviously we're not only interested in hallucination. I mean, there are very different questions that can be asked. There can be questions that basically need some sort of like reasoning, some sort of like summarization capabilities, and so on and so on. So I mean, we focus definitely also on that. And finally, we are definitely trying to, well, save money and time by being able to generate the data automatically. Because as I said before, like this is pretty critical to get the data, or I mean, obviously to get the data, it's like a huge problem, but to get the relevant data, which cover the problem somehow, how to call it, like uh, wide enough. Basically, we need to cover like all possible like edge cases and all possible situations that can happen. It's very, very time consuming. So, I mean, we are also trying to come up with a solution to this problem. And eventually, yes. That's exactly like what we are trying to do this. That like you basically have the documents, you are defining the scope of the problem, and we are trying to basically create the data or assemble the data from the corpus, from the knowledge base, so that we try to think of like different edge case scenarios. Obviously, like basic factuality of the data, and so on and so on, and eventually come up with some suggestions, some actionability for you, because we assume that not everybody is the expert. So we basically need something that can be taken into action and somehow being able to mitigate the problem if possible. Obviously, that's a hard one, but we can try. So as I said, like the scope is very important. We scope it to like specific system. We call it the model host, which is, let's say, a RAG application. Technically, it could be even like agentic application, but for purposes of this demo, we will use like a RAG. And then the RAG obviously have like specific configuration, which is also very important, because if the configuration changes, if you, let's say, change the parameters of the models, the response changes dramatically, and you cannot say anymore that it's reliable. So this is important. We need to know like the setup at which we are basically using. And finally, as I said, the scope, which are documents. We call it the corpus set. Knowledge base, let's say if you are heavy users of the Amazon, there are many terms, but basically those are the data that you are trying to generate the answers from. And finally, I hope I'm not talking for too long, so I will try to speed up the steps. So the first step of our workflow, our MRM workflow, is called the topic modeling. So maybe to your question, how do we generate like representative data? First of all, we need to understand like the common themes in the data. So the topic modeling exactly tries to do that. We are looking at the problem a little more from like statistical or like numerical perspective, and we are not just trying to guess the questions answers. We basically convert the documents, the corpus set, into numerical space using some embedding models, and then we are trying to cover the embedding space via some representative examples. We obviously chunk the data and then like try to like cluster and detect like maybe some patterns in the data, so that we have like representative sample of questions and answers that could be like found there. I wanted to emphasize that like this is pretty important, because if we were just, let's say, trying to like randomly guess the questions somehow, the answers and the questions don't necessarily need to be grounded in the corpus. I mean, we would be basically relying purely on the LLM that it doesn't make mistakes. And we are doing it vice versa. We are basically using the numerical space so that we can basically assure that like questions and answers are found within the original document set, within the original like corpus, and then like, I mean, evaluate it. I mean, it's kind of vague, but I hope I made it clear. So anyways, in a context of our use case, call center use case, as I said, the corpus is some banking manuals, policies, etc. And the topics that we can find are things like, I don't know, cash handling or overdraft prevention or certificate of deposit terms and conditions, and basically stuff like that. Those things don't necessarily need to be like, let's say, perfectly humanly understandable. The thing is that we are still using like complex models to basically, I mean, detect and also like generate the data from it. So I mean, basically there is some how to call it, like it can be a little vague. I mean, there is some space for, I mean, maneuvering, where we can maybe even like edit the topics and clusters eventually ourselves, or even like add ones if we feel that it's not representative enough. But I mean, this is basically iterative process. So I mean, we have to definitely like play with it, and all of these things basically take time to.
Can I ask a question? Is there any subject matter expert included in this process?
Subject metrics?
Yeah, like banking expert or some
No.
person who knows the.
Right now it's not needed because we are trying to automatically detect not the expert, but like let's say the knowledge found within, or I mean the themes of the knowledge that are found within. So we don't need it at this point.
What about topic identified is the wrong topic, or let's say?
Of course, for that, like for the clarity, yeah. I mean, we definitely can run it through the domain expert. Yeah, but as you know, as the topics are grounded in the data, we can be sure that they can be found there. That they are not fabricated or hallucinated randomly. So, I mean, that's why we sort of don't need it. That's why we can skip it. Anyways, when we have the topics, when we have some themes, we can start generating the questions. And the problem again is like how we generate the questions. We either need like some domain expert or like great collection of questions collected from the customers that have been asked, or we try to basically cheat a little and maybe ask again, I mean, super knowledgeable models about that. And that's what we are basically trying to do. We basically have different kind of question generators that focus on various aspects of the problem. So as I mentioned before, it could be reasoning. It could be like numerical reasoning. It could be temporal, or like reasoning about time, how it goes. And it can be also like questions that are sort of vague, ambiguous. It could be like simple factual questions. It could be like one letter answer questions and stuff like that. So we basically have like a set of generators that we connect with the topics that we find, and then we try to generate the questions. So basically we are trying to find all like different combinations of this, which we eventually use later for like some analysis and identification of maybe like weak points or problems. So the text generation is exactly about that. And again, like there is human factor involved. Like within all of the steps, I mean, we believe that it's necessary that the human is in control, that it cannot be completely automated. So human can come in and say, this answer is incorrect, or I mean, this needs some editing, or I think that, I know, people would ask this question instead of this. So you can, edit manually, etc. Or, I mean, we even, I don't know if I have, yeah, we have a screenshot, excellent. In this picture here, we can see something called the topic cluster graph, which is basically just some 2D projection of like the embedding space where we can see like detected patterns. And if we feel that like there are not enough questions asked about like the credit cards, we can select like specific regions and just generate more. So the idea is, again, like this is iterative process. This is not something like one-off solution which will, give you the golden stem of like H2O that you are safe. It's really about like playing with it and understanding it. So this is why the MRM is not really like one application, let's say. It's sort of like set of tools, analytical tools that should help you understand and mitigate the problems. Anyways, finally, for the text generation part, we obviously need to make sure that those questions actually make sense. We have let's say BMW. We absolutely need to make sure that the questions are not about like some, motorbikes, or, it could be, right? But let's say the city bikes. That would be bad. So we need to somehow make sure that the questions and answers are relevant to like what we are feeding the system. And that's what this is about. We again use, almighty models for various things. We actually often fall back to primitive mathematical methods and actually use like cosine similarity and stuff like that. But there is definitely some rigidness, some, exactness in that. So we are trying to definitely like make sure, things make sense. And finally, we can actually start evaluating and doing the analysis. So we have a test set. Now we basically need to run the system through various like performance checks, which can be, of course, like focus on, let's say, the retrieval part, which can be focused on being able to not answer with fabricated answers, but also, especially like in the banking sector, basically any sector that's working with people, that we are, for example, not biased. Let's say generally biased or anyhow else, and stuff like that. And then, of course, like we need to evaluate somehow the capabilities to, let's say, summarize text, or I don't know what else. There are like at least like 30 different techniques that we do, that we try to check, and then help you understand what happened by like some interactive visualizations, which I get to like later with now only quick demo because like time is running fast. Sorry. And of course, the MRM, as I mentioned, is part of usually like larger process in the company. If it's governance, if it's like separate process completely, there needs to be usually some traceability, some reports, something that basically report to your leadership usually. So we are also making sure that you have the materials. We produce like various artifacts, reports, machine processable artifacts that basically you can, feed in another ML system or AlterX or whatever you do for analysis and play with it more. So this is also like what we make sure you have. Yeah, sorry, for the evaluation techniques, I really wanted to just maybe in context of the call center, wanted to like bring up some that actually could make sense. So for example, the groundedness, it's more rigid method for like evaluating hallucination. So often in business, we can see that the hallucinations are measured by some again, sort of like deep learning style models, whereas there are maybe more mathematical methods that can be done. So groundedness, answer relevancy. So basically we need to make sure that like what's being answered is actually relevant to what has been asked. So stuff like that. Obviously toxicity, fairness bias, as I mentioned, we need to make sure that the answers are, let's say, they're not incorrect, like from society perspective, but also from like various like more moral perspectives. And finally, things like leakages, which is often like huge problem. We actually try to push the models also to basically give us the answers that they shouldn't be giving. For example, we're trying to, let's say, convince the models to give us or to communicate in some encoded language so that, basically we surpass the normal guardrail that are preventing the models to answer to those things and try to, steal something. So some things like that. Just in the context of the call center, as I mentioned, groundedness, the hallucination is obviously like fundamental. We'll get to it actually during them. We can save time. Anyways, last but not least, from like the evaluation perspective, again, we need to keep the human in the loop. If we do the evaluation and just, let's say we have 86% groundedness of all answers, it basically gives us nothing. I mean, the metrics also need to be set in context of the data and of the problem that we are basically trying to solve. So what we are trying to do is to, I mean, if there is a need, show a sample of the evaluated data and ask the user if they agree with what they see. If they agree, let's say, with the decision that the model or our evaluator made. So, I mean, as simple as, I mean, this is the question, this is the answer. We are saying that this is hallucinating. Like, do you agree or not? Or do you agree that the answer is like biased against, let's say, some gender or some race or not? And I mean, we of course like create small sample and calibrate the evaluators or the parameters of the evaluators, the configuration of the evaluators by the answers automatically, and then back propagate that to the evaluation and analytic part. So now we can start actually with the analysis and actually what we are trying to do to basically detect the problems within the models. The first thing that we are trying to look at are various types of weaknesses. Weakness is like very generic term, but I mean, from high level perspective, weakness is, I mean, basically area or some sort of maybe like form of a question that's being asked that causes troubles to the model. So we basically can see some sort of performance drop on that area. To maybe give you better idea, for example, the model is perfectly fine with answering all of the banking sector, I mean, questions, but it fails to answer for some reason questions about like credit cards. So in that case, we actually can do something about that. We can maybe fix the corpus, like, you know, maybe there is a problem with the data, with the policies. I know there are so many tables that the system cannot parse them on, or stuff like that. So this way, actually, we can, you know, do something about that, like create actionability, which I get to later. So anyways, those are weaknesses. And there are actually a few ways how to look at the weaknesses. The first one, I think the most automatic one that we developed is called the failure clustering. We are sort of automatically trying to like detect the weakness patterns, let's call them, by taking all of their failures, i.e. the test cases that somehow failed to pass the evaluation. Let's say they fell under the threshold, or we, you know, detected some sort of like bias, toxicity in them, and then look at different aspects of the answers. Let's say the answer itself, the retrieved context, or how the answer was generated, for example. And using this and some, you know, some smart clustering, some, again, like ML models, we basically detect like common themes, I mean, within the failures, same as we did with the topics, and try to inform the user about that. So we cannot really tell you that you can fix it this way. We can tell you there is probably some problem with this. So we are, let's say, not really giving you like error code if you would be doing the CI. We are giving you warning that, I mean, beware, there may be a problem. So that's first thing to do. Here in the example of the call center, we basically, again, took the failed test cases and clustered them. And we can obviously see that there are some themes, I mean, some two chunks that probably are somehow related to each other. So we ask LLM to summarize them and maybe tell us like 3 common things that they have, the test cases. I didn't mention it explicitly, but the test case means like a prompt, the generated prompt, expected answer, and maybe, I mean, you know, some ground truth that we see, and then of course like the actual answer that the model provided. Anyways, another way to look at the weaknesses is basically to look at it marginally. So we can look at the performance of the model aggregated by certain aspects, such as type of question. As I said, like we have different like generative, for example, yes or no questions or simple factual questions. And we are looking at the distributions of the scores of the actual answers to tell if there is problem in some, some combination, let's say, of the topics or the query types, i.e. yes or no questions or stuff like that. So in the image here, we can see like straight away that, I mean, this seems pretty fine, like the distribution is, I mean, overall after the threshold, the red dotted line, whereas like yes or no questions are sort of iffy, that there is some failed case. And maybe if you like try more, I mean, generating more, we actually can get into more trouble. So that's definitely something that we should be inspecting. This is actually, again, like example of the I mean, banking use case where we have the groundedness, the measure we use for assessing the hallucination, or I mean, to be exact, one of the measures that we assess the hallucination with. And we can see that, I mean, in this case, like the answers are like probably fine. The next thing, other than the weaknesses, we are looking at when analyzing the model's performance is the robustness. What's the difference? So as I said, like weakness is usually sort of like vulnerability to certain like property of the question, such as like type or, I mean, the topic that it's asking for. The robustness is basically like resistance or like, well, robustness obviously of the system to different variations. The first type of the variation is called, I mean, we call it the input variations, but in general, imagine that we are basically introducing different kind of mistakes, either like syntactic or grammatical into the prompts. So we can take the generated test that we use for evaluation, but now let's say we run through all of the prompts and try to do, like some basic typos. Or let's say coming from like not being able to speak language very well that we are using to communicate, maybe we like mistake some antonyms, some opposite words of, I mean, the opposite meaning words used in the sentence, and then we observe how the system responds. And obviously, in some cases, we basically want to make sure that, okay, if somebody replaces I with a Y, we would assume that the system responds okay, I mean, the same way. But if there is opposite meaning word, we could assume that there could be like difference, right? I mean, the answer that we get is, instead of like, I mean, your credit card rule, you basically get something like, I don't know, I cannot respond. That's like the ideal scenario. I don't understand, I cannot respond, right? So we are detecting things called flips, where like the original metric or the metric on the original test set passed or failed, but on the perturbed one, on the variated one, actually failed, or I mean, vice versa, passed. So this is like the first type. We have different types of perturbators. Don't need to go into that, but as I said, like there are grammatical and syntactical ones, and like basic keyboard typos. There are many ways to do that. I mean, but there is another type of the variation, and that is actually something that can be malicious, which is maybe even more important. So if there is some malicious user using our system, we need to make sure that we are still pretty safe. So this step is more about like pushing the model out of its bounds by, let's say, introducing questions that are out of the scope, that are, for example, somehow ambiguous, or like introducing like negations to, I mean, in the questions itself, and I mean, seeing how the system responds. And first of all, we are again looking at the flips as I like defined them before. So if the response or like score of the response changes with those kind of variations, and then of course we are also looking at the distribution shifts. So I mean, well, naive assumption would be that like if system performs well on the original data, there will be probably some performance drop on the adversarial, as we call it, like input. So we are trying to basically like play with it. And I mean, repeating it probably for like 100th time, this is all iterative. It's not like one-time thing. So you really have to play with it and try to like understand where you are looking at. So this is really a set of tools. So, well, this is actually like the last piece that I wanted to talk about, the MRM, but looking like high level at the whole workflow, all of the steps are actually reproducible or repeatable, so that you should get like reproducible maybe results, or like at least not quite maybe the same answers, but at least, you know, like same kind of problems, or detect like similar issues with the model. Yeah, I think I covered that. And finally, now we perform the analysis. What do we do about that? Like, we actually need to mitigate the problems, right? And that's why we have something, or we are trying to automate that by, of course, like providing you like the summaries and reports for the traceability, for the supervisors, or well, the leadership. But then also like trying to proactively make some suggestions. So first of all, we are able to, for example, detect problems with, with the robustness, or like with the common like variation problems. So, for example, we can somehow patch the system prompt, or like the configuration of the system, so that the system is basically more aware, or is trying harder, with certain like types of questions. We can detect also problems with certain topics or certain types of the questions. So we actually can extend the corpus used in the system in production with, let's say, FAQ section. So, our, like risk management detected that you are pretty weak on the credit card questions. So here is the set of like the most, or you can call it yourself, but here is our set of most commonly asked questions and answers to them. So when the such question arrives, we actually have the answer prepared, and we are not just like, hallucinating it from, arbitrary table in document. And finally, the guardrail. The guardrail is like, again, like super important, and also like pretty popular term in recent months. It's basically a measure taken to make sure that the system is maybe not responding if it's not sure, or in our case, we are also trying to like embed the guardrails that are watching, different aspects of the answer, such as like toxicity, properties like the hallucination, if possible, using like retrieve context and stuff like that. So this is actually like the third one that we do. Yeah, anyway, these are just the examples of the answers that I mentioned. And now we actually can do a quick demo, if possible, of the tool. Unfortunately, I spoke for too long, but okay. So this is the EvalStudio. First of all, I will be showing just the workflow, but as I said, like the EvalStudio is not really like one of application that just does the workflow. It's collection of tools for like evaluating, generating the tests. And actually, if you don't have the tests or don't have the data, we even have, the huge library of test cases ourselves, which we collected from, like different benchmarks or different papers that you can maybe start with. If you basically don't know like what the system will be used for, you can start with the well-known stuff. So this is the call center agent application that I mentioned. And the first step of the workflow is called the topic modeling. I have the internet again, so all good. Here we can see the graph that I mentioned, which was basically produced by this, automagical algorithm that basically tries to detect the themes. We can see like the detected topics or themes that we detected within the corpus. And as you can see, like the process itself has some configuration. We are, as I mentioned, using like different models for doing this, different model for like detecting the topics, different model for clustering, different things for doing the dimensionality reduction, so you actually can look at it in just 2D, not like ND space, etc., etc. So all this requires some configuration. We have some default, but obviously you can play with it and maybe get better answers. The second step that I mentioned is the test generation. As we can see here, I already have like well-prepared demo, but obviously this is iterative process. It takes time. I think that we need to emphasize that it's not like instant. It takes some time to get generated, but as you can see, we have different kind of generators that we can use. We can, obviously simple stuff like simple factual questions, yes or no questions, but also something that can be pushing the model a little out of the bounds, like asking out of the scope questions. So sometimes we deliberately want to basically ask about like city bikes, even though our documents are about the BMWs, and stuff like that. And finally, a way to select like what we are generating the test for. So maybe some topics are not representative enough or incorrect, or sorry, not this one. Or we basically may need to configure, which chunks of the text specifically we need to use. Or, as I said, we can basically select just an area of the graph that I want to focus on and use, just a sub area of the corpus to generate more. So stuff like that. The test validation part, I hope it's clear enough. This is, I think, well-prepared demo which actually works. So we don't really see, huge problems with the test cases. So obviously, like those distributions are more or less fine. There is, good correlation of like what was generated and what was found with what was found in the corpus. So yeah, just an idea how it looks basically. One of the aspects is definitely like being able to drill down into like what we are looking at. So obviously we can like give you more details, and in case like something doesn't feel right, you can either delete it if it makes sense, because like in some steps it doesn't make sense, or edit it in place where possible. And finally, our signature piece, which is the evaluation. The evaluation part actually does a lot of like interesting stuff. And produce this artifact called the evil eye, as somebody started calling it. This is just a visualization, interactive visualization that you can use to actually drill down into like the answers and actual performance of the model. I will just like quickly show you. So in the actually it's called, I think correctly, the sunburst plot. In the circular thing, we can actually see like outer and the inner circle, where we are trying to like categorize the evaluation techniques. So some are focused on the generation, some are focused on like privacy or leakages, and then of course like fairness and toxicity. So for sake of this example, let's look at the generation part, the groundedness, the hallucination one. We can see that the model overall performs with 0.86, which is probably not telling us much, but we can drill down more. We actually can see like the distribution of the performance on every test case that we used, and we can go even more into detail and drill down into like specific answers. This is pretty simple one, but we can even show like the performance on like the sentence level. So we are, actually trying to show you where exactly like the problem happened, and obviously like the retrieved context that was used, that you maybe can compare to see if it was grounded or maybe we made mistake. And of course, like you can do some shuffling with the visualizations and stuff like that, but I guess we can skip that. More important is probably like the artifacts that we actually create. One of them is called the problems and insights. We like those. We are trying to be proactive and show you basically what's the problem. So we basically try to be smart and show you maybe which question exactly is the problem. So in some cases, let's say one question usually causes problem to different evaluators. So we maybe try to notify you that, oh, maybe you are asking wrong, or maybe the answer itself, the question itself is a problem and not the model. And then also some insights about, like, as you can see here, what is the weak point for the evaluator. You should focus probably on that more. Of course, the setup, explanation of the evaluation techniques, least but not least the artifacts. So One of them is called the evaluation report. This is like sort of printable version that you can use to assess what exactly was done on what exactly. So, I mean, basic things like the configurations, the data set used, and then like configuration of the evaluators, etc., etc. And usually, I mean, much of the information included in the report is actually also found as sort of machine processable files on the downloadable report zip file, which contains various CSVs, JSON files, etc., that can help you understand the problems more. Of course, I mean, it's an enterprise application, so there are things like sharing or access control included, so you can share the stuff, you can import and export the evaluations for repeating it or sharing it with colleagues. And also sort of like hidden assumption was that you basically have some sort of access to the model host, to the system. We actually can perform the evaluation also on a system which is like offline. You basically can assemble those like evaluation needed files yourself and just give it to the system for evaluation and get actually all of their artifacts, which is pretty cool. So yeah, sorry, back to my workflow. The fifth step of the workflow is the calibration. As I said, we basically give you a random sample of the answers. In this case, we are looking at answers, semantic sentence similarity. In layman words, basically looking at how much relevant the answer is to actually what was asked. You, of course, have the selection of all of the evaluators that have been used and can calibrate all of them like individually, obviously, because there is a difference between like labeling, for example, groundedness. I mean, you can say that some of the answers are grounded in the context, in the corpus that was retrieved, but the answer may be not relevant to the question, which is a problem, of course. So that's why it's separate. And finally, the failure clustering. As I mentioned, basically trying to somehow find common themes within the failures and then maybe summarize them. Generators, topics. There's just like some distribution plots, so we can see maybe on which topics like the model performs, and the other weakness detection techniques. So basically looking at the problem marginally. So for example, this is pretty good actually, but for the groundedness, for example, looking at the distribution of the answers grouped by or aggregated by specific topics, we can detect some weakness patterns in the data. Again, query types and actually the combined view called like bivariate analysis, which is basically just like 2D metrics of, let's say, topics versus query type aggregation. And then the robustness testing. As I mentioned, the first type is the input variations. The input variations are basically trying to introduce different kinds of semantical and syntactical variations to original inputs. As you can see here, this is the original input, and here basically we did something like shuffling of the words. Like, what if, I know, I'm dyslexic and I'm just, putting the words in wrong order, or just, yeah, I know, my cat jumped on my keyboard and suddenly there is some variation. So things like that, where we can see that, the answer suddenly fails, which was like originally passing. So this is actually the flip that I mentioned. And finally, the robustness testing for the adversarial inputs. Basically a system, a tool that's introducing different kind of like questions that the system shouldn't be prepared for or are somehow like misleading or something, and then comparing the distribution, comparing the answers, again computing some scores and basically like notifying you about like possible problems with the system. If we go back to the overview, here we can see actually like the summary, maybe some quick mitigation strategies that you can do, and then like downloadable artifacts or the whole MRM process, like the report, or in this case, like the guardrail configuration. I want to mention that obviously there may exist a system which has no flaws. So in that case, you probably don't need any artifacts. So like those artifacts are actually dynamically created based on our findings. It's not like, statically said you will get everything. You basically get what you have problem with. So something like that. And I think that's actually all for my demo. I mean, we have definitely more topics within the EvalStudio, but maybe now it's time for your questions or maybe some clarification if needed. Thank you.